Thank you for attending this meeting. In this session, we will cover time value of money calculation. So we'll go over a quick definition of the concept we're trying to cover, and the focus then will be to perform these calculations in Microsoft Excel. Now, these calculations are important because they will be used throughout the corporate finance course. This is the mathematics of many of the equations that we will cover in the corporate finance course. So it's imperative to make sure that you understand and can perform the techniques that we're going to introduce today. So let's begin by sharing our screen. Let me make this a little bit bigger. So the first and fundamental and very important calculation that we want to introduce is the present value calculation. So let's introduce what the parameters are. FV is the future value. That's the amount that you're going to get in the future. PV is the present value or the principal. That's the amount today. I is the annual interest rate, and N is going to be the number of periods. And for what we want to do, it's going to be equal to the number of years. But is it flexible? Yes, it is. So what if you wanted to do 3.5 years? If it was 3.5 years, N would be equal to 3.5. And basically, what we're asking is we want to go out there and, let's say, have $10,000 in the bank in 5 years and we can invest at an interest rate of 3%. This equation answers the question, how much do we put in the bank today so that in 3 years at 5% interest rate, we'll have $10,000. So down here are some other equations that I put. They're basically the same thing, but just different perspectives on this same concept. All right, so let's go out here and try this Excel example now. You can see this Excel example I have at the beginning, at the top of the screen here. Let me make this a little bit bigger. All right, so you have the answer there. But in this case, the question is, we want $100,000 in 10 years and we can invest at a fixed interest rate of 3%. You have the answer there. You see that it's 74,409.39. So what does that mean? How much do we have to put in the bank today to get this $100,000? 3% interest rate in 10 years. So right here then, this is telling us then that we have to put $74,409.39 into the bank today, and we don't make any withdrawals at all during that time. How much do we need to put into the bank? 74,409.39. So you see the 74,000 presented algebraically here, but let's perform this in Excel. So you can see then that I've put some of the parameters in already, and I'm going to cell reference in this case. Whenever you're going to do Excel, go out there and cell reference so that you can perform scenario analysis, and we'll introduce that in a second. Okay, so in this case then, the Excel function that we want to do is equals the 100,000 divided by left parentheses, 1 plus the interest rate, right parentheses, raised to the number of years, and that's right here. I'll have to type that in. That's G39, right parentheses. Okay, G39 is where the number of years are. So you can see then that this is going to take a little programming, and this is basically kind of Fortran programming that you need to put into Excel. So again, that's equal to the future value divided by left parentheses, 1 plus the interest rate, right parentheses, raised to the number of years, right parentheses. So because you're dealing with a programming language, you have to follow the parameters of that program. And what's one basic rule here? The number of left parentheses has to be equal to the number of right parentheses. So be careful and be aware of that when you're constructing your equations. So let me hit enter here. And you can see, there we go. So there's our answer. Let me format this because it's money. We want to format it to 2 decimal points. And you could see that we're able to replicate the answer that was already given to us. Now, let's go out here then and let's try some scenario analysis. So what if you can go out there and get a 5% interest rate? How much would you need if you can get a 5% interest rate? I'm just making up these numbers, and in 8 years. In 8 years. So you can see that because in cell right here, G40, we've programmed those numbers in, we've cell referenced. Instead of typing the hard numbers in, we can perform our scenario analysis, and once we program it in, we let the computer do the work for you. So it's difficult and tedious to program it in originally. However, the benefits of these programs come into play when you perform your scenario analysis. So now I'll change it back to the original parameters, 3% interest rate, 10 years. And you can see then that we have the original answer. We have another problem here. Let's make this a little bit bigger. So we have another problem here where the answer is given to you, but basically you want $150,000 in 10 years, and right here at a 10% interest rate. So let me do this one where I'm going to plug the numbers in. And remember, if you plug the numbers in, you lose the flexibility to perform scenario analysis that we did in this example, but that's okay. Let's see how this would look if we plug the numbers in. So this is going to be equal to 150,000 divided by left, 1 plus 10%. The 10% needs to be inputted in decimal notation, raised to the 10th power. So in this one, no cell referencing was performed. the numbers were hard coded into the equation. And that's what we come up with here. So there we go. We're able to replicate make this a little bit bigger. Let me format this. So we're able to replicate the answer that was given to us. And again, this is hard coding the number in. Now, I prefer that you always set these up, your equations up as a cell reference, so that you will gain that flexibility that we introduced a little bit earlier. All right. Now, the next topic that we want to introduce and this is called an annuity. This is called an annuity. And what is an annuity? An annuity is a series of equal payments or receipts. The key word there is equal. So you're going to receive the same amount every year. Could be every quarter or every month, but we'll set this up as a year. So you're going to receive the same amount every year. You're going to receive $50,000 per year for the next 20 years. $50,000 per year, it's the same amount. You're going to receive that series of payments over the next 20 years. And by definition, that's an annuity. So let's go out here and try a problem, and we'll go out there and put the explanation on that. Now, the present value of the annuity factor, you can see here, then it's a little bit more complex. So we have the present value of the annuity factor, and instead of I, they're using R in this equation. N is the number of years. Here's the equation again. They have I as the interest rate. It's the same as R here. All right. And the only thing I don't like about these equations is right here, what they're putting in front of there. What they should have put there is the future value amount. They should have put FV instead of P. They should have put FV instead of R here. This R is not related to this R. These numbers are the future value amounts that you're going to receive. So it's a little bit more of an involved calculation. So let's go out and see how this one is going to be done. So let's try an example. All right, so you see then that I have the numbers that I just mentioned. So you want to receive $50,000 per year for the next 20 years. And when you're working with an annuity, you're going to lock in to an interest rate. So we're going to earn 5% per year for the next 20 years. So we have the future value, we have I, we have the number of years. Now you can see then that this calculation is involved. I'm gonna do this. And bring it down here. So instead of trying to program it in all together, let's go by pieces. Let's try this by pieces. And you can see that in this equation, remember this R should be a future value. It's going to be 50,000. So you see that in this equation, this 1 plus I to the n power is common to both the numerator and denominator. So I'm going to call this the base. And I don't think that's the official name, but just for our purposes, let's call this the base. So the base then will be equal to, and I'm going to cell reference again, left parentheses, 1 plus the interest rate, right parentheses, raised to the number of years. So that's going to be equal to left parentheses, 1 plus the interest rate raised to the number of years. And right here then, I'm going to come up with, let me round these a little bit more. Let's put these at 4 decimal points. Probably more actually, but so here, 1 plus 5% raised to the 20th power is equal to 2.6533. And you can see this 2.6533 will be substituted in here and then substituted in here. Now the numerator is going to be equal to the base minus 1. The numerator is going to be equal to the base minus 1. So this is going to be equal to the base minus 1, 1.6533. The denominator is going to be equal to the interest rate, right here. It's going to be equal to the interest rate multiplied by the base. So this is going to be equal to 5% times the base, the 2.6533. And you come up with 0.1327. So you can see now that we've calculated the numerator and we've calculated the denominator. So the present value of the annuity factor, everything within the parentheses. Now we want to calculate everything within the parentheses. That's going to be equal to 1.6533 divided by, and that should be G83. And that's going to be equal to 12.4622. So let me do a little formatting here. And you could see now that the present value of the annuity factor will slide down into this bottom portion here. So this is equal to this. And we have the future value, and we just want to pick one. So I'm going to choose the 50,000. I'm going to cell reference again. And you see the cell reference there. And so this tells us then that 50,000 times 12.4622 is equal to 623,111. I'm just going to round it just for our purposes to 623,000. So what's the question then? What's the question? The question becomes, you're going to talk to your financial advisor to set up an annuity for yourself. You tell the financial advisor that I want 50,000 per year for 20 years. And he'll tell you the current interest rate environment is 5%. I can invest it for you for 5%. They do the calculations, and the investment advisor will ask you then, I need a check. You need to give me 623,111 to set up that annuity for yourself, to receive 50,000 per year for the next 20 years. So what's going to happen then is that the annuity is set up. you're going to receive 50,000 in year one, 50,000 in year two, 50,000 in year three, so on and so forth, 50,000 in year 18, 50,000 in year 19, and 50,000 in year 20. When you receive that 50,000 in year 20, your bank account will be zero. Your bank account will be completely dry. And you can see that it's somewhat of a good deal, right? Because 50,000 per year for the next 20 years is equal to $1 million. How much did you have to pay to receive that $1 million? 623,000. So you're going to get, and just rounding off here, you're going to get an extra 375,000. You're going to get an extra 375,000. Where did that extra 375,000 come from? That's the interest that accrued over time. That's a lot of money. That's a lot of money. You're getting, if that's 375,000, you're getting almost 7 years of payments for free. That's the power of annuities. That's the power of annuities. So you can see then that this is maybe not that unusual. Maybe not that unusual. You've heard how retirees and old people, they set up annuities for themselves and they received a fixed income. So they're going to receive, they live off a fixed income. They're going to receive 50,000 per year. They're going to receive 50,000 per year. All right. How did they do that? They set up an annuity for themselves. They set up an annuity for themselves. And they pay 623,000. How much did they receive over the life of the annuity? $1 million. Not a bad deal. Not a bad deal. So the question comes, and from a real life standpoint, the question becomes, well, where do they get the 623,111? Where's the retiree or the old person going to get that money? Right? Where are they going to get that money? That's from their 401k or their IRA, their individual retirement accounts. All right. And they have an individual retirement account. They're going to roll over their individual retirement account and set up an annuity for themselves to receive the 50,000 per year for the next 20 years. So where does this initial amount come from? That seems like it's substantial. But where does it come from? They save that money using a 401k or more commonly now, an IRA plan. So that's why for you young people, I strongly encourage you to start your IRA accounts as soon as possible. It's difficult because you may need that money, but you're going to need it a lot more in the future than you will now. So be financially prudent and set up your 401k or your IRA accounts now. And you can see that I have this set up so that it's going to be flexible. So you're going to do scenario analysis and you're going to ask, well, what if I want 75,000 per year? I'm just making up these numbers. 75,000 per year. I can get an 8% interest rate over 15 years. So if you want to receive 75,000 per year, 8% for the next 15 years, how much do you have to invest today? The present value of this annuity, $641,961. But you can see then the calculation. So to get to this point right here, you see cell G84 that's everything within this parentheses. Difficult to program in, just straight. Okay, and so even for me, I don't. I mean, I could probably do it, but I might make a mistake. I might be stumbling and bumbling around before I get the right answer. So break it out in pieces like this, and you're still going to get the same answer. And if there is some type of problem, it's easier to debug a short equation than it is one big long equation here. Now, the next concept we want to introduce is present value, but now it's done on a continuous basis. For the previous problems that we had done, we assumed that interest was going to accrue once a year, like this one. But now, in this case, we want the present value when it's done on a continuous basis, and that's going to use this formula, and where E is equal, you have your future value, E is a mathematical constant. It's kind of like pi. E is equal to 2.718 negative R, which is the interest rate, negative T, which is time. So instead of the interest accruing just once at the end of the year, tiny bits are being accrued every second over the life of your investment. So it's the same question. If I want an amount in the future, how much do I have to invest today? The key difference between the first equation that we've done and the second equation is that, again, in the first equation, the compounding all occurs at once at the end of the year. Under continuous compounding, tiny bits are done every second. And so you could see here then that I have the formula. Here, e to the negative RT. Up here, this is more accurate because they have FV. I don't like A here. They should have put FV, the future value, e to the negative RT. This is okay. This is okay. Don't worry about this equation. Don't worry about this equation. All right. Here's another equation. Only look at for this example, it had multiple references. Only for this one, only look at the red circles. Only look at the red circles. So future value, E is the mathematical constant. This is difficult to see. Negative I, which is the interest rate, times N, which is the number of years. Negative I times N, which is the number of years. All right, and here's another one. The present value, only look at the red circle. The present value is equal to the future value times E, all raised to the negative interest rate multiplied by the number of years. The negative interest rate multiplied by the number of years. So again, the interest is being compounded continuously now in this case. So here we are, we have this example. We have this example here. Let's see if we can replicate it. Oh, they don't give us the answer on that, which is too bad. But again, here's the formula. So how are we going to do this in Excel? How are we going to do this in Excel? So equals, and let's cell reference. I'll do it both ways also. Equals, let me do it the hard input way first. So this is going to be equals to 1,100 times left parentheses. How do we get that E in Excel? That's going to be equal to the function EXP. EXP. That's E in Excel. Raised to, and you don't have to put the raised to sign here now, but this is going to be equal to negative 8% times 2 years, right. So how do you raise to E in Excel? EXP. So let's round these to 2 decimal points. So what is the question here? I want $1,100 in 2 years, and I can invest at 8%. How much do I have to put into the bank today? How much do I have to put into the bank today? $937.36. Okay, so what is that? About 100 and about $63, $163. That's the interest that'll accrue continuously over those 2 years. So let's try this now. And the preferred method for our course is to always cell reference so that you can perform your scenario analysis. So equals to the future value times left parentheses EXP left parentheses. Now this has to be negative. You have to put the negative sign there, 8%, and then times the number of years. I can't, so I'll just have to type that in, times G154, right. And that's programming it in by cell referencing. And again, I'm not going to go through this, but you see the point. Why do you do this? To perform your scenario analysis. And there's the same answer twice. All right. And so let's make sure that we're building up some of the intuition here now. So let's say then that you want $1,100 in 2 years. But instead of being able to invest at 8%, you can invest at 12%. So let's do the scenario analysis here. Let's put this as 12%. And you can see now, remember this was based off the 8%, but this is telling us then if you can invest at 12%, you need to put in $865, which makes sense, right? You can invest less money because you're going to earn a greater interest rate. Your money will be working harder for you, therefore you can invest less to get the same amount. So let me change this back to the 8%, and we'll stop here. So thank you for viewing this lecture, and if you have any questions, please contact me. Thank you very much.